does not occur naturally in a pure state. Instead, it is usually found alloyed with other platinum group metals in geologically unique rock formations called layered intrusions. The vast majority of the world's platinum reserves are concentrated in just a few of these mineral-rich intrusions. South Africa contains over 70% of known global platinum resources. Russia is the second largest platinum producing country, providing around 20% of global output. Outside of Southern Africa and Russia, platinum mining occurs on a smaller scale in North America and Zimbabwe, which accounts for around 5% of global platinum production. Its scarcity makes platinum rarer than gold. If you were to take all of the world's gold and fill an Olympic-sized pool with it, you could fill 3 entire pools. If you take all of the world's platinum reserves, you would only be able to fill 1 pool up to your ankles. Platinum's rarity adds to its investment appeal and drives the price skyward. Most platinum mining occurs underground because platinum ore lies far below the surface, sometimes hundreds of meters deep. This makes underground hard rock mining the predominant technique for extracting platinum. This involves digging a vertical shaft deep into the earth and using elevators and hoists to move equipment, ore, and workers between the surface and the mine. Drilling and blasting are key parts of underground platinum mining. Specialized equipment like long hole drill rigs bore into the rocky face, inserting explosives to break the ore into manageable fragments suitable for hauling to the surface. The drill hole patterns are carefully designed by geologists to optimize breakage and safety based on deposit characteristics. After blasting, mucking machines clear away the blasted ore and transport it to the main shaft using underground rail or vehicle haulage. From there, a complex system of cages and conveyances lift the raw platinum ore to the surface for the next stage of processing. Underground mining for platinum is technologically advanced, but also dangerous work with many risks and challenges requiring extensive monitoring and safety measures. This is only the first step in the process to make platinum usable for the world, a process that can take up to 6 months to complete. Once the blasted platinum ore reaches the surface, the first step of processing is mechanical separation. The ore is crushed by machinery into small fragments and mixed with water to form a slurry. The ore slurry is then ground in a mill to the consistency of beach sand to further expose the platinum powder. After milling, the platinum ore goes through froth flotation to enhance concentration. Chemical reagents called collectors are added to make platinum particles hydrophobic or water repellent. Aeration tanks then blow air into the slurry, allowing hydrophobic platinum grains to float to the surface in a mineral-rich froth which overflows for collection. The platinum concentrate collected by froth flotation contains about 15 to 20% platinum group metals, along with other residual minerals like copper and nickel. To isolate pure platinum, this concentrate first undergoes a high-temperature smelting process where impurities are burned or melted off. The remaining substance is called matte. Additional smelting stages continue removing impurities from the matte, eventually yielding a nearly pure platinum end product ready for final chemical refining. To refine platinum even further, the smelting process continues. After crushing and grinding the dried platinum concentrate, it is blended with fluxes like silica and borax to lower impurity melting points in the smelter. Inside the extremely hot smelting furnace, reaching over 2,500 degrees Fahrenheit or 1,400 degrees Celsius, the molten material separates into layers based on density. Lighter impurities in iron form a top slag layer that is drained off, while dense precious metals like platinum sink to the bottom for collection. This process is repeated over and over to continue to remove impurities. Further refining is required to isolate pure platinum. The matte goes through several acid baths, precipitations, filtrations, and furnace sequences to remove sister metals. Finally, aqua regia dissolves the remaining platinum, which can then be filtered, dried, and heated to form a pure platinum sponge or powder ready for manufacturing. Once in its purest form, platinum is now ready to be transformed into usable daily cases. In jewelry, due to platinum's bright white luster and scratch resistance nature, it's a long-lasting choice for fine jewelry and intricate wire designs. In healthcare, platinum is used in chemotherapy medications, pacemakers, and used to slow the growth of tumors. In the automotive space, platinum is used to reduce harmful exhaust emissions and is responsible for the majority of vehicle catalytic converter demand. In the military industry, platinum coats jet engine parts and is a strategic mineral for various other defense technologies. With a resume like that, it appears that